That check engine light is on. You get it scanned. The scanner spits out P0741. You look it up. It says, torque, converter, clutch circuit performance, or stuck off. Your heart sinks. Most people hear that and think the worst. They picture their transmission in pieces on a workbench. They see a repair bill with lots of zeros. Many shops will jump right to a rebuild or replacement. That is a very expensive job. It can cost thousands of dollars. It is often the first thing people suggest, but it is not always the only answer. You do not have to panic just yet. This code scares people for a good reason. The torque converter is a major part of the automatic transmission. When it has a problem, it can feel like the whole transmission is failing. You might feel shuddering. You might feel slipping. Your fuel mileage might get worse. It is easy to assume the entire unit is shot, but P0741 is a circuit code. That word circuit is your first clue. To fix the problem, you first need to understand the parts involved. Let's talk about the torque converter. It is a fluid coupling. It sits between your engine and your transmission. Think of it like two fans facing each other. One fan is connected to the engine, the other is connected to the transmission. It blows fluid at the transmission's fan, making it spin. This is how your engine can be running at a stoplight while the car is not moving. This process is not very efficient at highway speeds. There is always some slippage, which wastes fuel and creates heat. This is where the torque converter clutch, or TCC, comes in. The TCC is like a clutch in a manual transmission. Its job is to create a solid mechanical link between the engine and the transmission. When the car's computer decides it is time, the TCC engages. It locks the two halves of the torque converter together. This eliminates that fluid slippage. It makes the connection one-to-one. This direct link improves your fuel economy. It also reduces the amount of heat the transmission generates while cruising at a steady speed. The P0741 code means the computer tried to lock the clutch, but it did not see the lockup happen as expected. It monitors the engine speed and the transmission input shaft speed. When it commands the TCC to lock, it expects those two speeds to become nearly identical. If it sends the lockup signal and still sees a significant difference in RPM between the two, it knows something is wrong. The clutch is slipping when it should be locked. After seeing this failure a few times, the computer will turn on the check engine light and store the P0741 trouble code. It is the computer's way of saying, "Hey, I told the clutch to lock, but it's not listening to me." Before you grab any electrical meters, you must start with the most basic check. Look at the transmission fluid. The fluid is the lifeblood of the transmission. The fluid does more than just lubricate. It cools the moving parts. It provides the hydraulic pressure to shift gears. It provides the hydraulic pressure to lock the torque converter. If the fluid is low, old, or dirty, it cannot do its job properly. This alone can cause a whole host of problems, including P0741. This is the easiest and cheapest thing to check, so never skip this step. You will need some clean rags. You will need gloves. You may need a funnel. This procedure is different for every car, so you must consult your owner's manual. Most older vehicles have a dipstick for the transmission. For these, the engine usually needs to be running and the transmission warmed up and in park or neutral. On a level surface, pull the dipstick. Wipe it clean. Reinsert it fully. Pull it out again to read the level. If it is below the full or hot mark, it is low. Low fluid can cause the pump to suck in air, which leads to low hydraulic pressure and slipping. That slipping can prevent the TCC from locking up. Many newer cars do not have a dipstick. They have a sealed transmission with a check plug and a fill plug. The procedure for these often involves getting the car up on a lift or jack stands, perfectly level. With the engine running, you remove the check plug. The fluid temperature is often critical for an accurate reading, sometimes requiring a scan tool to monitor it. If a small trickle of fluid comes out, the level is correct. If nothing comes out, it is low. Low fluid is a major red flag that must be corrected before you do any other tests. If the fluid level is correct, the next step is to add the correct type of fluid. Using the wrong fluid is just as bad as having low fluid. Different transmissions require very specific fluid types, like ATF +4, Mercon V, Dexron 6, Check your owner's manual or the dipstick itself for the exact specification. If you need to add fluid, use a long, clean funnel to pour it in slowly. Add a little at a time and recheck the level frequently to avoid overfilling, which can also cause problems. If the fluid is clean and at the proper level, it is time to move on to electrical testing. This is where you will find out if the solenoid or its wiring is the culprit. For these tests, you will need a good digital multimeter. You will also need a service manual for your specific vehicle to get the correct specifications and wire locations. The first and most basic electrical test is to check the resistance of the TCC solenoid's coil. You do not need the engine on for this test. First, you must locate and disconnect the transmission's main electrical connector. Sometimes the TCC solenoid has its own external connector. Often it is part of a larger harness. With the key out of the ignition, disconnect the connector. Inspect both halves for any signs of damage. Inspect for corrosion on the pins. Inspect for fluid intrusion. Sometimes transmission fluid can wick up the wires and contaminate the connection, causing issues. Now, set your multimeter to the ohms setting. You will be measuring the resistance across the two pins that lead to the TCC solenoid inside the transmission. Your service manual will tell you which two pins to test. Touch one probe of your multimeter to each of the specified pins on the transmission side of the connector. The meter will display a resistance value. Most TCC solenoids have a resistance between 10 and 30 ohms when at room temperature, but this varies widely. Check your manual for the exact range. If the reading is within the specified range, the solenoid coil is likely good. If your meter reads OL or infinite resistance, it means the coil wire is broken and the solenoid is bad. If it reads a very low number, like near 0 ohms, the coil is shorted and the solenoid is also bad. A reading that is within spec is a good sign, but it is not a complete pass. It just means the coil is not broken or shorted. The solenoid could still be mechanically stuck. Also, remember to check the wiring leading to the solenoid. Wiggle the harness while you have the meter connected. If the resistance value jumps around, it indicates a broken wire or a loose connection somewhere between the main connector and the solenoid itself. This type of intermittent fault can be tricky to find, but is a definite cause for a P0741 code. After checking resistance, the next step is to check for power and ground at the connector. This tests the wiring from the computer to the transmission, along with any related fuses or relays. For this, you will need to plug the connector back in. Set your multimeter to DC volts. You will need to carefully back probe the connector. Slide the thin probes down the back of the connector until they make contact with the metal terminals inside. Be very careful not to damage the wires or the weather seals. With the ignition key on but the engine off, check for power. One of the two wires for the TCC solenoid should have battery voltage, around 12 volts. This is the power supply wire. If you do not have 12 volts on this wire, you have a power supply problem. It uses a small but critical part called the lockup solenoid. A solenoid is simply an electromechanical valve. It has a coil of wire inside. The car's computer sends an electrical current through that coil. That current creates a magnetic field. The magnetic field moves a small plunger, a valve. That movement opens or closes a passage for transmission fluid. The TCC lockup solenoid directs fluid pressure to engage the torque converter clutch. It's the bridge between electronic command and hydraulic action. The lockup solenoid is the prime suspect in most P0741 cases. These solenoids live inside the transmission, bathed in hot fluid. Over time, they can fail. The electrical coil can break, an open circuit. The coil can also short out. The mechanical valve can get gummed up with dirt and debris. If it gets stuck, it won't move when the computer commands it. Either way, it cannot control the fluid flow needed to lock the converter. If the solenoid fails electrically, the computer usually detects it immediately. It can detect an open circuit. It can detect a short. That detection can set a P0741 code instantly. If the solenoid is mechanically stuck, it's different. The computer sends the signal, the electrical circuit tests fine, but the valve doesn't move and the clutch doesn't lock. This is the most definitive test. Section 5. What to look for. Fluid color level smell. Once you have confirmed the fluid level is correct, evaluate its condition. The color, clarity, and smell can tell you a lot about the health of the transmission. Healthy new automatic transmission fluid is typically a bright, translucent red or pink. It should look clean and clear. Over time, it will darken to a brownish red. That's normal to an extent, but it means the fluid is aging and losing effectiveness. Do not want to see dark brown or black. Dark, opaque fluid signals severe age contamination or overheating. Now, smell the fluid. Healthy fluid. Slightly sweet, oily smell. A transmission running too hot will burn the fluid. Burnt fluid smells sharp and acrid, almost like burnt toast. Very dark fluid plus burnt odor. Excessive heat inside the transmission. That heat can be caused by slipping, directly related to P0741. Dirty fluid is the enemy of the TCC solenoid. Clutch material, tiny metal particles wear off and contaminate the fluid. That creates gritty, abrasive sludge. Sludge can clog tiny valve body passages. It can clog the small filter screen on the TCC solenoid or cause the solenoid's internal valve to stick. When the solenoid is clogged or stuck, it can't direct fluid flow to lock the torque converter, even if electrically fine. This is a very common cause of P0741. If your fluid is dark, smells burnt, or looks dirty, a fluid and filter change is your next logical step. Don't just drain and fill. Drop the pan and replace the transmission filter. The filter catches much of this debris. With the pan off, look for a magnet inside. Fine gray paste on the magnet is normal. Large metal shavings or chunks on the magnet are a sign of serious internal damage. If the fluid is just old and dirty, new fluid and a fresh filter might free the sticky solenoid and solve the problem. You will need a 12-volt power source like the car's battery, and a set of fuse jumper wires. Using a fuse is critical for safety. It will prevent damage if you accidentally short something out. Do not apply power for more than a second or two. This can overheat and burn out the solenoid coil. Connect one jumper wire to the ground terminal of the solenoid and the other to the power terminal. Briefly touch the other end to the battery's negative post and to the battery's positive post. When you apply power, you should hear a distinct solid click. This is the sound of the internal valve moving. No click means the solenoid is mechanically stuck and must be replaced. A weak click could mean it is partially clogged with debris. If it clicks loudly every time you apply power, the solenoid is most likely functional. If all these electrical tests pass, your P0741 is likely not caused by a simple electrical fault or a bad solenoid. If your fluid is clean, if the solenoid tests good, if the wiring is intact, then consider a more serious mechanical problem. P0741 can be set by failure inside the torque converter. The clutch inside the converter is a friction plate similar to a manual transmission clutch. Over many miles, that friction material wears away. When it wears, it loses the ability to grip. When the computer commands lockup, the worn clutch slips, creating the RPM difference that triggers P0741. One common symptom is a shudder or vibration. You might feel it when cruising at a steady speed, typically 40-60 mph. It can feel like small bumps or a rumble strip. You might also see engine RPMs fluctuate while holding highway speed. That's another sign the clutch isn't holding. Strange noises can also point to a bad converter. A failing bearing, a damaged turbine fin, can cause whining, grinding, or rattling. Those noises may change with engine speed and be louder when the transmission is in gear. Another major sign is lots of metal debris in the transmission pan. A fine gray paste on the pan magnet is normal, but shiny metal flakes, slivers, or chunks mean hard parts are grinding apart. That's a terminal diagnosis for the transmission or converter. This is usually where DIY repairs should stop. Replacing a torque converter means removing the entire transmission. It's a large, heavy job needing a proper lift, a transmission jack, and specialized tools. If you've done external checks, fluid filter, solenoid wiring, and the problem persists, especially if you have symptoms like shudder or metal in the pan, it is time to seek professional help. You've done your due diligence and can go to a shop with solid diagnostic info. Before you make that call to a mechanic, let's review the steps you have taken. This checklist will help you organize your findings. It will also show the mechanic that you have done the proper groundwork. This saves them diagnostic time and saves you money. Presenting a mechanic with a logical list of tests and results shows that you are an informed owner. This is your no-rebuild roadmap, the core of the FixCarCodes philosophy. Follow it, and you will be in the best position to make a smart decision. 1. Code and data. Did you read the code with an OBD2 scanner? Did you save or write down the freeze frame data? Speed, temperature, RPM when the code was set. 2. Fluid condition. Level, color, smell. Is it full red and clean, or is it low dark and burnt? 3. Fluid and filter. If the fluid was dirty, did you perform a pan drop fluid and filter change? 4. Solenoid resistance. Did you test the TCC solenoid's resistance with a multimeter? What was the reading in ohms? 5. Wiring inspection. Did you inspect the wiring harness and connector, physical damage, corrosion, loose pins? 6. Power and signal. Did you back probe the connector to confirm power? Check for a signal from the computer? 7. Solenoid function. Did you safely bench test the solenoid with a fused 12-volt supply? Did it click? 8. Pan debris. When you had the pan off, what did you find? 9. Driving symptoms. Shutter slipping or strange noises while driving. Now you are at a decision point. If your tests pointed to bad fluid or a faulty solenoid and you replace them, the problem may be solved. Clear the code and drive the car to see if it returns. If all your electrical and fluid checks passed, but you have a persistent shutter and found metal in the pan, the problem is almost certainly internal. At this point, your best move is to take it to a trusted professional. You can confidently tell them, "I have a P0741. I've confirmed the fluid is good, and the TCC solenoid and its circuit are working. I suspect an internal torque converter failure." P0741 is an intimidating code, but it does not have to be a financial disaster. By following a logical diagnostic path, you can often find a simple and affordable solution. Start with the fluid. Test the electronics. Rule out the cheap and easy fixes before you even consider the expensive ones. This methodical approach is what separates a parts changer from a true diagnostician. By taking these steps, you have empowered yourself, saved money, and learned a great deal about how your vehicle works. That is how you keep your car healthy and on the road without breaking the bank.